through very well. And I'll post questions on the previous topics so that you can yes, Brighton, students from DBIT semester 1 are supposed to be taking this course. Okay, so it is for DIT Sem 1, DBIT Sem 1, and CIT Sem 1. Okay, so you are supposed to be part of the class. Okay, so let's look at expressions, equations, and identity. How do the three relate together? Okay. So what distinguishes or what identifies an equation is the equal sign. Is the equal sign. Okay. That's what makes an equation be called an equation. Okay. So it relates to different identities, or what we call terms in mathematics. Okay. Relates to different identities, or what we call term in mathematics. Okay. So like the example given there, 3x minus 5 is equals to 1. 3x minus 5 is equals to 1. That's an example of what an equation should look like. Okay, that's an example of what an equation should look like. Another example is f is equals to 9 over 5 c plus 32. Okay, so this is also an equation. And we know that 9 over 5 here is normally called a coefficient. The same happens to 32. Okay, although 32 will be called a constant, but the expectation is that if this equation is supposed to satisfy a given level of degree, like a given level of a degree, like the cube, the square, and or the linear, then the expectation is that the unknown here has a power of 0. So that is why we are not able to see it. Okay, but now these are called coefficients, and I'm sure most of us are aware of that. So 9 over 5 and 32 there will be referred to as coefficients. And the most commonly known equation is y is equals to mx plus c, which is an equation of a straight line, okay, where m is always supposed to represent the gradient, okay, while m is supposed to represent the gradient. So this is one of the equations that is commonly known, okay, is commonly known. Then what are these identity that we talk about in an equation? So identity will define the relationship between the values within an equation. So it's a range of values that when plugged into the equation, then they'll be able to give us the expected solution. When plugged into an equation, they'll be able to give us the expected solution. So for example, (3x minus 5 is equals to 1 is an equation. Okay, and since it is true when x is equals to 2, that is, if you plug in 2 here, you're able to get the answer that we are talking about, which is 1. Okay, which is 1. Then we can say 3x is approximately equal to 8x minus 5x. So that we can call an identity, since it is true for all values of x. It's a range. Okay, that's actually what we are talking about here. Is a range that you can be able to plug in and be able to get your content. Then from there we have what we call the simple linear equations. That's where we derive our equations. And I was talking about a concept here called degree. Okay, so our equations will classify them in terms of the degree. We call them the degree or the order of the equations. Okay, basically they refer to as the power with which the unknown value is represented. Okay, the power with which a known value is represented. So it's fortunate that when we talk about the power, we know what the power is all about. Okay, so we're going to classify them as we move on. We're going to do the classification as we move on. Okay. So solving an equation, I'm sure we all know about that process. We all know about that process. How to solve an equation, just trying to maintain the order in the equation, to balance the equation. That's what we mean by solving an equation. So basic examples are given there of what you can be able to see in an equation. So for instance, solve for the equation 4x is equals to 20. That's very basic, and you can be able to get x with a lot of ease. You can be able to get x with a lot of ease. Just divide both sides by the coefficient of x, and you're able to come up with the value of x for that particular equation there. Okay. So we are balancing, we're just trying to balance that equation so that the left side and the right side are able to balance. What we used to call what you do on the left hand side, you ensure that you also do on the right hand side. That concept is very important when you'll be talking about completing square, just in trying to solve different quadratic equations. Okay, so more examples on how you can solve simple equations. So we have problem 2 there. 2x divided by 5 is equals to 6. So you are expected to get the value of x in that particular equation. You're expected to get the value of x in that particular equation. So you can see how the solution has been brought about. So in mathematics, of course, I'll have to pause for some seconds so that you can also pick what you're able to pick from the examples given there. I'll not be able to move with a lot of speed. So at least you copy one or two things for your own consumption. Okay, so a different example can be in this order. These are basically simple equations. Can be in that order, problem 3. Problem 3.
Problem 3.
So basically,
You add.
I'm getting a lot of echo. So kindly.
I'm getting a lot of echo. So kindly.
So you add 5 or subtract 5 from both sides just to be able to balance the equation. Just to be able to balance the equation. So problem 4 is the same thing. We'll not go into that again. There's quite a number of examples with the notes that I'm using that explain almost the same concept. So we'll not go into problem 4. So once you look at problem 3 and 2, and 1, you should be able to have known exactly the solution that we are struggling with here. Okay. So let's look at problem 6. Is a little bit different. Solve 6x plus 1, which is equals to 2x plus 9. So what you just need to do is very simple. Put the like terms together. I think we also talked about like terms in our previous class. Put the like terms together. Then add or subtract them together. Okay, so put the x's together and then put the knowns together. The knowns, of course, is 1 and 9. Also put them together. Then you can be able to solve by balancing the equation. If you are dividing on the right, you also divide on the left, so that you're able to balance the equation. So once you combine your like terms together, you arrive at 4x is equals to 8. Then you can balance the equation by dividing both sides to be able to get 2. Okay, so the type of equations we are handling here are called linear equations. Okay, the type of equations we are handling here are called linear equations. The reason why they are called linear equations, one, graphically, when they are designed or when they are plotted on a graph, they produce a straight line. Okay, so linear. Okay, of course, in a linear equations or on this type of equations, the expectation is that the unknown has a power of 1. That is the highest power that you can see for the unknown. Okay, so maybe before moving on, we also have to know that in an equation, we'll always have what we call the dependent and the independent variables within the equation, or dependent and independent terms or identities within the equation. So of course the independent is the one that controls the dependent. Okay, so like when you talk about some change in price, okay, that will have a net effect on the budget of an household. Okay, so when the price goes up, the household budget has to be changed. Okay, so you realize that the price here is what really influences or has an impact on the household budget. Okay, so price is going to be independent, and then the household is going to be dependent, because anytime the price changes, it affects the other the budget of the household. Okay, so in an equation, we're going to have such a balance, and that's why most of the time when we're solving equations, we'll try to balance the equation. Okay, we'll try to balance the equation. So that's another simple example of how you can solve simple equations. Esther says that there is a problem with the connection. I don't know exactly, is it the slides or is it the voice, or which one is missing? You can confirm which is missing so that I know. I propose the type of correction to be made. Yeah, propose the type of correction to be made. Yeah, and you have to tell me whether you are seeing the slides or not. You let me know. If you are listening, the audio you can be able to hear or not, you let me know, because I'm not able to see you guys, and I'll not be able to know whether the two are okay on your end. I tried to do a dummy one on my side, but I think it's really having a problem with the audio. It's giving me a lot of echo, so that I was trying to see what you're able to see so that I can balance when there's a problem. Okay, so more examples on what you can be able to do with the equation is problem 6. You can try and solve that. As I mentioned that problem 6 and the previous problem, is almost the same thing, and therefore we're not going to spend a lot of time trying to solve the equations with the same concept. Okay, trying to solve equations with the same concept. There are further problems there, or further equations that you can try and lay your hand on to be able to know whether you've understood the basic concept of collecting like terms and balancing the equation. Okay, so the equations there from 1, 2, 3, and 4. You can just able to try and see if you can be able to do that. That's very straightforward. In fact, that is number line. Okay, so basically that is just introduction of what we are supposed to do. We were not supposed to do that. That is purely number line, where you balance the negatives and the positives. Yes, so we are moving to the first type of an equation. How do we make use of them in mathematics? So I've said the first type of equations is the one with the degree 1, where the unknown has a degree of 1 or a power of 1, and it's called linear equations. It's called linear equations. And they're the ones we've mentioned here. They are the ones we've been putting in place here. But now, how do they contribute to mathematics? How do they contribute to mathematics? So let's look at solutions of quadratic equation, simultaneous equations. Solutions of simultaneous equations. Solutions of simultaneous equations. Okay, so this is where the linear equations come from, or this is where the linear equations find their use. So what are simultaneous equations? Simultaneous equations basically is a combination of two or more linear equations to solve a particular problem. And if they are combined in 2 or 3 forms, then one, whether we are trying to get a maximum point or a minimum point for a given 2 types of equations, okay? If it is sales versus the number of stock that is there, or it is buying price and selling price, you want to get the profit. Okay, so you'll get to know the meeting point of the buying price and the selling price, so that you know the profit margin. Okay, so that is where that such of scenarios is when we put up 2 or more equations of linear type together to be able to solve given life real situations. Okay, so that's what we call simultaneous equations, 2 or more linear equations. If the equation involves two unknowns. Then we call it two unknown or double linear equation. Okay. We'll have equations where we have three linear equations to be solved. Okay, so we have three unknowns. From mathematical perspective, it's always x, y, and z. So that is a three unknown. Where if you plot that particular graph, then you're expected to be plotting a graph that has three axes, x, y, and z axis. Okay, so we're not going to go into the deep presentation of that. That's what gives you the 3D model. Okay, that's what gives you the 3D model. But for this, we're just going to handle two a set of unknowns in each pair of simultaneous equations. So the introduction there says that only one equation is necessary when finding the value of a single unknown quantity, like what we've done in the previous content, where we have x alone in the equation. So you don't need more. But now, as the number goes on, if you have two unknowns, you are talking about x and y in a given equation, then you'll need two. You'll need two equations to be able to solve that. And that's where we start talking about the simultaneous equations. So we are saying equations that have to be solved together to find the value of the unknowns, equations that has to be solved together to find the value of unknowns are called simultaneous equations. And we can solve them using two methods. We can do substitution or we can do elimination. The graphical method is also an option that you can be able to use to solve such type of simultaneous equations. So we're going to look at the first two methods, substitution and elimination. We're going to look at the first two methods, substitution and elimination. Let's look at example 1. Or problem 1. Solve that particular set of unknowns, that is y and x, by applying elimination and substitution methods. By applying elimination and substitution methods. So let's begin by substitution. Generally, substitution will mean you look for either the value of x in terms of y or y in terms of x, then you substitute. That's the meaning. Okay? Express x in terms of y or y in terms of x, then substitute. I hope you remember the concept of making an unknown value the subject of the equation. Okay, making the subject of an equation. So that's what we're going to do in substitution. So let's look at how the solution looks like. Let's look at how the solution looks like. Okay. So by substitution process 1, we are making x the subject, as I was mentioning. In other words, we are expressing x in terms of y and any other variable that is there. So we've picked on equation 1 to do that. We've picked on equation 1 to do that. So how do you make x the subject? Push everything to the right and leave x on the side of the equation. Leave x on the left side of the equation. Remember, when you are crossing the equation mark, the sign transition or the changes that comes with the sign, okay? The changes that comes with the sign. Okay. So once we have x in terms of y, let's go to equation 2 and place that value on the right hand side of this equation here. Right hand side of this equation here. In any place where x is found. So that's what we're calling substitution. That's what we are calling substitution. Okay. So from here, anywhere we see x, we'll put -1, -2y. And that is what has been done here. Okay? That's what has been done there. Then, using your mathematical foundation knowledge, you can expand that equation, open the brackets. Open the brackets. When you open the brackets, you're going to get this value here. Okay? You're going to get that value there. How my shades are not are a bit clear. I'm trying to shade so that we move together. Then from there, you can collect like terms, the knowns together and the unknowns together. So the y's together, and then the ones with without known values together. So 18 and 4, negative 18 and negative 4 put together. Then we have 11 and not 11, but 8 and 3 also put together. So when we bundle them together, and we balance our equation, then we arrive at this process. We bundle our equation, we arrive at that process there. That's substitution. That's substitution. So you make x or y the subject. It doesn't have to be x or y. Sometimes there'll be w and a different type of value there. Okay. So unless somebody has an equation, somebody has a question. So after you found your y, then you do what we call backward substitution. When you found your y, you do what we call backward substitution to find your x. Okay, so you remember the equation that we had at the top there, this one here, when you were making x the subject. Okay, so we substitute the value of y into that equation and find our x. Then finally, the values that we have for x and y respectively is 3 and -2. 3 and -2. And we've solved our equation appropriately. We've solved our equation appropriately. So we can look at elimination, then I can give you 1 or 2 samples you try on your own. As you try, you'll be able to discover if there is a problem or not. Let's look at elimination. So the example we've been given is this: 2 sets of equations. 2 sets of equations. X plus 2y is equals to -1, and 4x minus 3y is equals to 18. So we are looking at the value of x and the value of y. So what do we mean by elimination? So substitution, we've known what we are supposed to do. That we make one of the unknowns the subject, express it in terms of the other unknown. So the way we expressed x in terms of y, then we can plug that into our equation and move on. Now in elimination, as the name suggests, I'll loosely say you kill one of the terms, of the unknown terms. Sorry. You kill one of the unknown terms. So like what we have here, you want to remain with one of the unknowns. So you decide what you want to eliminate. Who do you want to eliminate? So like the example provided here, we are eliminating x. We are eliminating x. Okay. So in the elimination process here, it's either addition or subtraction, depending on which terms that you have. Depending on which terms you have. So you can either subtract or you can add together. But first, you have to balance the equation so that you ensure what you have in equation 1 and equation 2, if you subtract or add, then they'll be able to go or be able to give you a 0. So like what we have here, if you check the previous equation that we had, okay, if you check the previous equation that we had in in B there, we had x plus 2y minus is equals to -1, and 4x minus 3y is equals to 18. So if you were to eliminate x, then definitely it means we have to balance the two. So to balance x and 4x, you multiply the equation by 4. Equation 1 by 4, so that you get 4x on both sides, so that if you add or subtract, then you'll be able to get a 0. But in that case, of course, we'll do a subtraction, because if you add 4x plus 4x, you're going to get 8. You're not going to get a 0. Okay? But now what you need to remember is like what we were saying up there, that what you do on the left, you must do on the right. Okay? So while you're balancing equation 1, ensure equation 2 remains the same or is also balanced. So in our case, we're only going to balance equation 1. Equation 2 is already in a format that we can be able to work with it. So if you multiply across with 4, then remember the 4 changes everything. Okay, the 4 should change everything. So we get 4x minus 3y is equals to 18. Then you subtract so that you get a 0 at x. So when you do your proper subtraction, then that's what you need to arrive at. So you'll have 4x minus 4x is 0, minus 3y minus 8y is 11y. Then 18 minus 4 is going to be 18 plus 4, which is 22. Okay, then you're able to get your 2 once you balance the equation by dividing both sides by negative 11, negative 11. You're going to get negative 2 as your answer. So since now you have the value of y, you just do what we already done. Just do the backward substitution on one of the equations, and you'll be able to find, especially the equation that did not change. You can use that, or still, even the other one that was just balanced, you can still be able to use it. You'll be able to get your solutions. You'll be able to get your solution. Okay, so unless there's a question on substitution and elimination, I'll give you like 2 minutes or 3 to solve problem 2. To solve problem 2. Solve problem 2. Okay, so that is correct, and see quite a number have been able to provide the right answer for that particular question. Let's try problem 6. Let's try problem 6. Let's try problem 6. Let's try problem 6. We can check the answer for problem 6 together. Is another version of simultaneous equations that basically involves fractions. Okay? So you really need to balance your equation before you can move forward. You really need to balance your equation before you can move forward. So basically, if you look at what has happened here, okay. So there's the equation is being balanced here. You can see we are multiplying both sides by we're multiplying both sides by 8. As the LCM between 2 and 8. Okay. So you're just trying to balance that by looking at the highest common factor. Okay. So from there, you'll be able to have gotten a better equation. From there, you should have been able to get a better equation. X plus 20 is equals to 8. Then you're trying to use elimination. For those who are using elimination, you're trying to work on equation 2. Okay. If you go back there, you'll see how equation 2 is 13 minus y over 3 is equals to 3x. So you're multiplying it by 3 as the highest common factor between 3 and, of course, 13. We can say it is 13 over 1. So between 3 and 1, 3 is the highest common factor. So you multiply by 3, then you arrive at that equation we are referring to as equation 4. Okay? What we are referring to as equation 4. The previous one, we refer to it as equation 3 after you've balanced that equation. Okay? Then now you have very known territory here with the two equations that you can be able to sort out with elimination or substitution. Okay? Then from there, now you can begin. You want to use elimination, you want to use substitution. What has been provided for here is the substitution, is the elimination. So we say you balance first, balance the equation. So you are looking at getting rid of y. So what do? If you're looking at getting rid of y, look at equation 5 and look at equation 6. If you want to get rid of y, then you go to equation 6 and multiply by 8 so that you get 8y. So that you get 8y. But now, because it is minus 8 then plus 8y, we have to agree what you really want to do. So the addition will go well with us, because minus 8y plus 8y will give us a 0. Okay, and then we'll remain with the rest. So if you remain with the rest, you can be able to get x with a lot of ease. So if you multiply this equation by 8, it will change itself. Okay, this is what will come out. That's what will come out. So as the process continues, if you add equation 5 and equation 7, as I've mentioned, addition will work for us, then you're supposed to get this. Then you can divide both sides by x, by 73, which is the coefficient of x, so that you can come to a conclusion of 4. You can come to a conclusion of 4. Okay. Then from here, you can use the value of x to calculate or obtain the value of y. You can use the value of x to obtain or calculate the value of y, which is going to be 3. This is going to be 3. Okay. Yes, any question concerning that? So that is what elimination and substitution is all about. The only thing that we need to look at is the application in scenarios where we have what we call in mathematics word problems, okay, where you have a set of scenarios that explain maybe a situation, then you're supposed to extract your equations there and provide some solution. So that's what we look at in our next class. That's what we look at. In fact, not in our next class. I'll try and record that and post it online. Then you can just have a listen to it. But meanwhile, we just to mention, next week we want to try and have a simple cut. Okay, next week we want to have a simple cut. What I'm trying to do is just to try and see how best on your side you can be able to we can be able to do exams online on your side. So I'm trying to see how best you can be able to do exams on your side when you're online. Okay. So next week we'll have a small cut. I'll do the setting on the platform, and then I can invite you to take that. So it will only be a cut from 3 topics that we've done so far. Okay. Cut from 3 topics that we've done so far. So what I want you to do as we finish up the class, what I want to do as we finish up the class, there's softwares that I'll share with you, or you can download them on your own, called Safe Browser. Okay, called Safe Browser. So you can download it on your own, install it on your machine. Okay, so we'll just have a small cut. So you can take this time, go and read, just revise what we've done so far. I'll post the notes for the 3 items, the 3 topics that we've looked at. We've looked at indices, logarithms, and of course, simultaneous equations. So you can just check, and then, yeah, next week we can see what to do. Okay. So unless there is a question, unless there's a question. Unless there's a question. So the remaining an hour, you can use it to rewatch the videos that were there previous, because I can see new people that have came in and who are not there in the previous classes. So you can catch up. You can catch up. Yeah, it's part of that cut that we will conduct from 25th. But now, of course, it will be the day of the particular unit. It's not on 25th, all of them. Okay, it's just a process that goes throughout the week. Our intention is to try and see how well can you do exams on your side. Okay. Yes. Yeah, so the new guys, you can catch up with the previous content that we've done in the remaining 1 hour. We can catch up on the remaining content. Okay, if there's no question, then we can stop there for today. So as I've mentioned, I'll record the last bit of the on simultaneous equations, the application part, and post it online.
You are currently the only person in this conference.